Hello everyone, this is Shweta Patil from Department of E&TC, AISSMS, Institute of Information Technology, Pune. Today we will discuss on the topic deadlock. We will see the introduction of deadlock first. When we are talking about multiprogramming environment, there are several processes which may complete for a fixed number of resources. A process requests a resource, and if the resource is not available at that time, it enters a wait state. It may happen that it will never gain access to the resource if that resource is being held by other waiting process. The formal definition of a deadlock is a set of process is deadlocked if each process is waiting for a resource that is held by a deadlocked process. So usually the event is release of a currently held resource. So none of the process can run, release resource or be awakened. There are 4 conditions for deadlock. The first condition is the mutual exclusive condition. In the mutual exclusive condition, each resource is either free or assigned to exactly one process. Next is the hold and the wait condition. A process may hold allocated resource while waiting for the allocation of the other resources. That is about the hold and wait condition. Next is the no preemption condition. Here the resources previously granted cannot be forcibly taken away from the process. And the fourth condition for the deadlock is the circular and the wait condition. So there must exist a closed chain of process, each of which is waiting for a resource held by the next member of the chain. And these 4 conditions can be modeled using a directed graph. So the graphs have 2 kinds of nodes. The process is shown in the circle and the resources are shown in square. So first figure tells that resource R is assigned to process A. Here the process B is requesting for resource S, and in the third figure the process C and D are in a deadlock over the resource T and U. So there are some strategies for dealing with the deadlock. Here also we can see there are 4 strategies. The first one is we can just ignore the problem altogether. The second is detecting and recovering it. Third one is the dynamic avoidance by careful resource allocation. And fourth is the prevention by negating one of the 4 necessary conditions. So here we are going to see the Ostrich algorithm. So this is one of the simplest approach which is known as the Ostrich algorithm. The Ostrich algorithm says that just stick your head in the sand and pretend there is no problem at all. So as the ostrich puts its head into the sand and he pretends that there is no problem. So the arguments in favor of Ostrich algorithm are like the deadlock occurs rarely in the system. The elimination of deadlock involves a large penalty in performance. If a system crashes more often due to the other reasons, that is hardware failure, software failure or the memory overflow, and deadlock avoidance could impose several restrictions on resource allocations. So many operating systems like Unix simply ignore the problem of deadlock. Next is the recovery from deadlock. So there are various ways of recovering from deadlock. The first way is recovery through preemption. So to eliminate the deadlock using resource preemption, some resource may be taken away from its current owner and can be given to another process. It may require the manual intervention in this process. So recovering through preemption is frequently difficult, or it is sometimes impossible also. Second is recovery through rollback. Recovery through rollback is dependent on checkpoints. Checkpoint a process means saving its states in a file so that it can be restarted later. Checkpointing contains some of the following informations: the memory image, resource state, the CPU register value, etc. And the next way to recover from the deadlock is recovery through killing process. So a simple way to break the deadlock is to kill the process from the deadlock cycle. After this, other process may be able to continue. If this doesn't help, it can be repeated until the cycle is broken. So killing of the process should be based on the minimum cost. Many factors may be considered here for which the process is chosen. Some of them can be including the priority of the process, how much the process has executed, and how much large the process will execute to complete, etc. So this was about deadlock. Thank you.